So you're sitting in a strategy meeting. The projector is humming, the coffee is getting, completely cold, and someone at the end of the table leans forward, steeples their fingers, and drops the ultimate corporate trump card.
Oh, we all know the one.
Right. You have undoubtedly heard it. You might have even said it yourself just to speed things along. They say, why don't we just move it to the cloud?
It has become the ultimate magic wand phrase in modern business, hasn't it?
Totally.
It sounds so clean. It sounds effortless. It basically implies that by simply shifting where our data lives, all of our operational inefficiencies, our security vulnerabilities, and, our hardware headaches will just evaporate into the digital ether.
Yeah, it's presented like this absolute cure-all for every technological constraint a business has ever faced. But today, we're taking a deep dive into this incredibly comprehensive research document titled Cloud versus On-Prem, Choosing What Actually Fits.
Which is such a necessary read right now.
It really is. And our mission today is to cut right through that meeting room jargon. We're going to figure out where your technology should actually live, and we're stripping away all the marketing speak to do it.
Because the marketing speak is pretty thick out there.
Exactly. So whether you are an IT veteran who architects these systems every single day, or, you're a business leader just trying to prep for your next budget review without feeling completely overwhelmed by tech acronyms, we see you.
We've got you covered.
We're going to break the underlying mechanics of this down together. Okay, let's unpack this, because the central thesis of our research today completely reframes the entire conversation. The cloud isn't automatically a superior state of being.
No, not at all.
It is simply another method of delivering technology.
And recognizing that distinction it's the critical first step toward making a sound architectural decision.
Yeah.
We have this societal tendency to view technological shifts as these binary evolutions,
Like the new thing completely kills the old thing.
Precisely. We assume that the new paradigm completely invalidates and replaces the old one. We assume the cloud is this entirely new dimension of computing.
Right.
But when we look at the physical reality of what we are doing when we, quote-unquote, move to the cloud, we are really just changing the real estate.
So if the cloud isn't some magical, ethereal realm, what is it practically doing for us? We certainly can't dismiss it.
Oh, absolutely not.
There are undeniable structural benefits to this model. It has fundamentally restructured how distributed teams operate. It allows for asynchronous collaboration in a way we couldn't do before.
Yeah, it's completely changed the game for remote work.
And it drastically reduces the amount of physical cooling and power you have to manage in your own office building. Plus, it gives a mid-sized business access to enterprise-grade computing power that would require, honestly, millions of dollars in capital expenditure to build internally.
Those are massively powerful economic and operational levers. You're essentially renting a fraction of a hyper-optimized data center.
Right.
So think about a team that needs to access a proprietary application, but the workforce is distributed across 4 different time zones.
Like they're working from living rooms, regional branch offices, airport lounges, all over the place.
Exactly. A cloud-hosted solution provides a centralized access point for all of them. The application isn't bottlenecked by the internet connection of your local corporate headquarters anymore. It's sitting on a massive internet backbone, accessible from anywhere with just a basic broadband connection.
And you also gain elasticity, right? Like if you are running a retail company and Black Friday hits, you can just spin up 10 extra virtual servers for that specific weekend to handle all the traffic.
Which is huge.
Yeah, and then you spin them back down on Monday, so you just stop paying for them. You don't have to buy 10 physical servers that will literally just sit in a dark closet gathering dust for the other 360 days of the year.
What's fascinating here is how quickly the research strips away the mystique of that exact elasticity with one incredibly grounding observation.
Oh, I love this part.
To quote the core finding directly, the cloud still runs on servers. They're just somebody else's servers, somewhere else.
That line shatters the illusion perfectly.
It really does.
When we think about that mechanically, moving to the cloud is basically like renting a fully furnished apartment in a luxury high-rise instead of owning a single-family house.
Oh, I like that. Walk me through the mechanics of that comparison.
Well, when you own a house, so an on-premises server room, you are entirely responsible for the foundation. If the roof leaks, you fix it.
Right.
If the HVAC system dies and the servers start overheating, you are the one calling the repair technician at 2 in the morning.
The dreaded 2 a.m. page.
Exactly. Now, when you rent the apartment, meaning the cloud, You are outsourcing all that infrastructure management. The landlord handles the massive cooling systems, the backup power generators, and, the physical security guards at the front desk.
Okay, yeah, that makes sense.
But, and here's the catch, you still have to organize your own belongings inside that apartment.
Right, they don't do your laundry.
Exactly. You still have to determine who gets a key. You still have to remember to lock your own door at night. The daily reality of living in the space, which is essentially the governance of the data, is entirely on your shoulders.
That perfectly illustrates what the tech industry calls the shared responsibility model.
Which people misunderstand constantly.
Constantly. There is this dangerous misconception in the corporate world that moving to the cloud means transferring all operational risk to the provider.
Like, it's just not my problem anymore.
Right. People assume that because their data is with some massive tech giant, it is automatically backed up, perfectly secure, and utterly immune to ransomware.
Which is a terrifying assumption when you actually look at the service level agreements.
It is genuinely terrifying because the provider guarantees the security of the cloud, meaning the physical facilities, the concrete walls, the hypervisors running the hardware.
The guards at the front desk.
Yes, the guards. But the customer is responsible for security in the cloud. If your administrator accidentally configures a database so that it is publicly accessible to anyone on the internet,
Oh, boy.
the cloud provider will not stop you. They will happily serve that data to whoever asks for it because, well, you configured it that way.
Wow. Yeah, they're just doing what you told them to do.
Exactly. Software patching, access management, multi-factor authentication, and most importantly, data backups. Somebody in your organization still has to actively manage all of that.
So if we still have to architect the software environment, secure all the user accounts, and manage the data backups ourselves, it begs an obvious question.
Which is?
What is the actual operational benefit of putting that server 1,000 miles away in a data center instead of just in a rack down the hall?
Right.
The research pivots here to examine the ongoing relevance of keeping things grounded on premises, or on-prem. But honestly, I have to push back on this a little bit.
Okay, let's hear it.
Wait, isn't maintaining our own physical servers completely outdated? I mean, the industry has spent the last decade trying to escape the headache of buying hardware, predicting depreciation, and swapping out dead hard drives. Why would any business voluntarily take on that capital expenditure today?
It does seem counterintuitive, right? Especially when we are all so focused on the convenience of cloud scaling.
Exactly.
However, the operational reality becomes very clear when we examine workloads that require high-throughput data processing.
Okay, give me an example.
Consider a scenario where a workforce is interacting with massive files all day. Think of a post-production studio scrubbing through uncompressed 4K video footage, or an engineering firm rendering complex 3D architectural models.
Or like a genomics lab processing those massive scientific data sets.
Exactly. Situations where the file sizes aren't measured in megabytes, but in gigabytes or even terabytes.
Right.
In those specific environments, the literal physics of network infrastructure dictate the best solution. If you move massive files to a cloud server, you introduce severe operational friction due to latency and bandwidth limitations.
Yeah, and let's actually break down that friction for a second because people often confuse bandwidth and latency.
Well, you do, constantly.
So bandwidth is the width of the pipe. It's how much data can travel at once. But latency is the physical speed at which a single data packet travels from point A to point B and back.
Right, the actual travel time.
So even if you have a massive enterprise-grade internet pipe, if the cloud server is physically located 4 states away, it simply takes milliseconds for each request to travel back and forth.
And those milliseconds compound. So if a video editor is trying to scrub backward and forward on a timeline, their software is making thousands of tiny data requests.
Yeah.
If that footage is sitting on a local server connected via a 10 gigabit Ethernet cable in the exact same building, the response is virtually instantaneous.
It's seamless.
But if that footage is in a cloud data center, the editor will experience these micro-stutters. It makes the day-to-day experience agonizingly slow, fundamentally destroying productivity.
And beyond just the user experience, there is a serious financial penalty.
Oh, the egress fee.
Yes, it is notoriously easy to get data into the cloud, but incredibly expensive to get it out. Cloud providers typically offer free ingress. Uploading data costs you nothing because, they want your business.
Right, come on in, the water's fine.
Exactly. But they charge for egress every single time you download or move that data back out to your local machines. So if a team of engineers is constantly downloading terabyte-sized CAD files from the cloud to work on them every day, those egress fees can quietly balloon into thousands of dollars a month.
Which brings us to another operational vulnerability: internet dependency. The research highlights a critical risk factor here. What actually happens when the physical connection to the outside world is severed? A business could have the most sophisticated cloud architecture on the planet. But if a construction crew's backhoe accidentally severs the local fiber optic line down the street,
Which happens way more often than people think.
way more often,
Yeah.
suddenly your entire distributed infrastructure is completely inaccessible. Your employees are literally sitting at their desks, staring at error messages until the internet service provider comes out and fixes the physical cable.
And that is the trade-off with on-prem. If the internet goes down, but your local network switch is still functioning, your team can still access the local server.
Exactly.
They can still render files, access local databases, and actually do their jobs. The local advantage is unparalleled speed, total control over your data movement, and immunity to external internet outages.
But we do have to acknowledge the flip side of that localized control.
Right.
That physical hardware has a life cycle. It demands a specialized IT presence on site. You are responsible for local and off-site backups in case the building itself suffers a catastrophe like a fire or a flood.
Yeah, you own the problem.
You do. You are trading the ongoing subscription cost of the cloud for the cyclical, massive capital expenditure of replacing server racks every 5 years.
Here's where it gets really interesting. When we analyze both paradigms, the highly scalable, outsourced infrastructure of the cloud versus the high-performance, predictable control of the on-prem server, it becomes obvious that neither solution is inherently superior.
No.
It is entirely a matter of matching the architectural mechanism to the specific workload.
If we connect this to the bigger picture, it requires us to completely discard the premise of that initial strategy meeting question.
Right, the whole why don't we just move to the cloud thing.
Exactly. Instead of debating should we be in the cloud or on-prem, a functionally mature organization asks a far more nuanced question. They ask, where should each specific part of our technology live?
It totally moves the conversation away from chasing tech trends and turns it into an exercise in logistics.
Yes.
And the logical conclusion is that for the vast majority of established businesses, the optimal architecture is a hybrid approach. It's about building a diversified strategy.
The hybrid environment really is the pragmatic reality of modern enterprise IT. A business can intelligently distribute its workloads based on their mechanical requirements.
So how does that look in practice?
Well, for example, deploying a cloud-based software as a service model for email, chat, and basic document collaboration like Microsoft 365 makes perfect sense.
Right.
Those applications require high availability from multiple geographical locations, they rely on small data packets, and they benefit immensely from the cloud provider's continuous security updates.
But simultaneously, that same exact business retains a heavy-duty local server array specifically designed to handle their proprietary manufacturing software or their massive design files, securing that zero-latency performance we were talking about. Rather than forcing one paradigm to do everything poorly, they let each environment do what it does best. You know, it reminds me of a balanced diet, or really, it's like a toolbox. You wouldn't use a sledgehammer to screw in a light bulb. You're simply choosing the right tool for each job. Actually, it also reminds me of designing a modern physical supply chain.
Oh, I like that. Elaborate on the supply chain comparison.
Okay, think about a major retail operation. You keep your high turnover, immediate need inventory in a small stockroom directly behind the storefront.
Okay, yep.
That is your on-prem server. It is immediately accessible, you control it completely, and there is zero shipping delay when a customer needs something right now.
Right, instant access.
However, for massive long-term storage and scalable inventory that serves multiple regions, you don't build a massive warehouse attached to every single retail store.
That would be ridiculous.
Right. You rent space in a massive regional fulfillment center, that's the cloud. It scales up when you need it. And you let a logistics company handle the building maintenance. You wouldn't try to cram global inventory into a local stockroom.
Yeah.
And you wouldn't make a customer wait for a warehouse delivery just to buy a daily necessity.
That is an excellent structural parallel. You are optimizing for proximity, where speed is required, and you're optimizing for scale, where reach is required.
So what does this all mean for you as you sit in your next technology planning meeting? I mean, how do you actually assess your own business workflows and decide which system belongs in the stockroom and which belongs in the fulfillment center?
Well, the research provides a highly rigorous diagnostic framework to run before authorizing any migration.
It's like a checklist, right?
Exactly. It forces leadership to evaluate the actual business impact, rather than just getting caught up in the technological novelty.
Mm.
The diagnostic approach clusters around three core areas of risk and return. The first cluster evaluates performance and reliability. So we have to ask the first question: will moving this specific application actually make our employees more productive?
Right, because if migrating a local database to the cloud means adding a clumsy VPN login step and a 2-second delay to every single search query a customer service rep performs, the answer is a definitive no.
No, absolutely not.
You are actively degrading their productivity.
Which ties directly into the next reliability check question too. Are we improving our uptime? Or are we simply trading localized hardware risks for broader internet connectivity risks?
That internet cable again.
Right. If a business operates in an area with notoriously unstable broadband infrastructure, forcing mission-critical applications into the cloud introduces unacceptable fragility.
Okay, and the second cluster of questions revolves around financial and operational risk. We have to look past the initial setup and ask question 3. What is the total cost of ownership over the next 3 to 5 years?
Such a vital question.
Because the cloud looks incredibly cheap in year 1 when you aren't buying physical servers. But when you factor in monthly licensing, storage growth, and those massive data egress fees we discussed earlier, year 4 can look like a financial nightmare.
It really can. And operationally, we must return to the shared responsibility model for question 4 and 5. The framework demands we ask: what happens if our internet connection goes down? And how will our data be backed up? And who is actively monitoring it?
Yeah.
Because moving to a cloud provider does not absolve the organization of implementing a robust disaster recovery plan.
The third and final cluster is perhaps the most strategic, and honestly, it's the one most companies completely forget until it is way too late.
Oh, without a doubt.
It focuses on vendor lock-in and exit strategy.
This raises an important question. If our business model changes, or the cloud provider just decides to double their pricing, how easily can we extract our data and move it somewhere else?
Yeah, in the industry, they call this data gravity. As a data set grows in the cloud, it essentially gains mass. It attracts more applications, more services, and more integrations. And eventually, the data becomes so massive and so entangled in that specific provider's proprietary tools that moving it to a competitor or bringing it back on-prem becomes financially and technically impossible.
You are trapped.
You're completely trapped. This framework forces you to engineer your exit strategy before you even sign the initial contract.
By applying these diagnostic clusters, performance, financial risk, and exit strategy, you strip the emotion and the marketing right out of the decision. You are left with a purely objective view of what the technology actually does for your specific organizational goals.
And the ultimate takeaway here isn't to declare a winner between cloud and on-prem. The goal is to build a customized, intentional infrastructure that serves the actual human beings doing the work, rather than forcing the work to bend to a technological trend.
Exactly. I mean, infrastructure should remain invisible to the user. It should simply work.
Let's bring all of this together. We started by dismantling the myth of the cloud, realizing that it isn't some untouchable digital realm, but simply somebody else's server running in a massive, optimized facility.
Yep.
We redeemed the on-prem architecture, proving that for massive files, data gravity, and raw speed, localized control is often the superior choice.
Oh, without a doubt.
We explored how a hybrid approach acts like a well-designed supply chain, mixing the speed of a local stockroom with the scale of a regional fulfillment center. And finally, we broke down a diagnostic framework to help you evaluate productivity, financial risk, and vendor lock-in.
You now have the analytical tools to critically evaluate any proposed architectural shift, ensuring it aligns with operational reality rather than just boardroom hype.
But before we wrap up today, I want to leave you with one final provocative thought to mull over something that expands on everything we've uncovered today.
Oh, I'm ready.
If we accept the foundational premise that the cloud is merely the current delivery mechanism for technology, what happens when the next delivery mechanism arrives? We are already seeing the rise of edge computing, where processing power is pushed out of centralized mega data centers and back into local devices and cell towers.
Yeah, it's definitely starting.
The pendulum is already starting to swing back. So if you dedicate all of your organizational energy to perfectly optimizing where your servers live today, are you neglecting to optimize the adaptability of your team?
Wow. Yeah.
Ultimately, the physical location of your technology matters significantly less than your workforce's cultural capacity to adapt when the technological landscape shifts entirely once again.
That is the ultimate strategic advantage. Hardware depreciates, delivery mechanisms evolve, but a resilient, adaptable human culture that is the only true constant in business operations.
So the next time you are sitting in that strategy meeting and someone casually suggests, why don't we just move it to the cloud? You have the exact framework to challenge that assumption. Keep questioning the buzzwords, look for the underlying mechanisms driving the technology, and as always, thank you for taking this deep dive with us.